all the background material into their heads. Oh, 2 days, 3 hours, 42 minutes. This is going to be a problem to cover this area in 20 minutes without you having all the background, but I'll do my best. IPv6. Simple, beautiful. If you connect to the FOSDEM network, you run IPv6 only. You're happy, things work, mostly. No. But more things work this year than last year. But this is fairly simple. If you move your stuff and you port it to IPv6, both server and client, things will just work. It's just more bits on the IP packets. DNS, TCP, UDP, everything works like before. No problems. This was the world we saw in the mid-90s when we said that, well, IPv4 is dying so fast, so it's going to be gone before year 2000. No. But at FOSDEM, at least, it's gone. So I'm not going to spend much time on this. You all know IPv6, right? You all use IPv6 networks, right? Cool. This is where we get into trouble. We have two stacks. We have the old legacy dying, creepy, scary, insecure IPv4 network, and we have the IPv6 network. And we end up in situations where the client wants to connect to a server and suddenly have the choice of two different paths. We have two different protocols bringing us from point A to point B. This is like putting my wife behind the wheel and trying to explain you can go this way and that way, and she's going to block and like, what? And then I end up saying go that way. We did that in the RFCs. We said go IPv6. If you have IPv6, IPv4, go IPv6. This turned into a problem. Microsoft have done a lot of good things with IPv6. They actually, in a Windows release, enable IPv6 for every single computer through automatic tunnels. So your Windows desktop believed it had IPv6, firewall blocked it. Sites that actually published IPv6 DNS records for the same host name got into trouble because the browser said, Google's not reachable, Facebook not reachable, which wasn't very good for marketing. Didn't help the brands when everyone thought the servers was down. So they immediately disabled IPv6, which is not what we wanted. The solution to all of this is happy eyeballs. In the ITF, we created a standard specification saying you should not start with IPv6 and then when you fail, move to IPv4. You should connect to both. IPv6 could give it a few milliseconds head start, right? But connect to both, mostly at the same time. And the first that responds, you keep that connection, close the other one, and you'll be happy. The users will be happy, the marketing people will be happy, and we can safely migrate to IPv6. So the browser vendors, they implemented all of this. On June 6, a few years ago, we tested live on the internet. Facebook, Microsoft, Google, everyone turned on IPv6 on the same host names, and nothing happened. All browsing succeeded. Everyone was happy in their eyes. Marketing people was happy, and we had IPv6 back in DNS. Happy eyeballs, connecting at the same time, not doing it serially, and continuing on the session that opened first. That's great. Well, on mobile phones, I frequently see that we have multiple interfaces. So now we have IPv4 and possibly IPv6 on the mobile cell phone network, and then we have Wi-Fi. Whew. Should we set up 4 connections? 10? Where's the limit? I have devices with 4 SIM cards and Wi-Fi. So the new world is giving us problems. And what happens, what we see, is that on mobile networks that add IPv6, the IPv4 network is suddenly behind a NAT, a carrier-grade, professional, high-end, cool NAT, not a small-end family home router stuff you have at home. This is a professional carrier-grade NAT, which makes it no fucking better. Right? Real-time protocols and NAT doesn't love each other. But that's not the end of it. They have session management on the network. They're adding a lot of boxes to manage stuff, to make your experience better, which practically kills everything you want to do real time, because to make things better, they close down IP flows to give room for new IP flows, to make new users happy. So your concurrent session in the background to your XMPP server, go. Your WebSocket, crash, burn. No fun at all. So we see that the IPv4 network is quickly dying. We have cell phones in production use in the National Public Radio, where I spend a lot of time these days. We're moving heavily towards IPv6, which gives us a very clear path for the live broadcast audio directly from that device to our studio. The IPv4 network, everyone complains. But what we see with these mobile apps is that networks come and go. Suddenly the network you're using and you're having so much fun with, disappears. But another one just showed up, that was really bad. Going back. This is making life really, really hard to have live, real-time connections, bi-directional. So happy eyeballs, well, that's a start. But we really need to focus on this in SIP. We need to have session resumption, like the previous speaker talked about with XMPP. We need to be able to move our sessions. In multimedia, that's called ICE. There's some cool stuff in ICE. Saul mentioned it. But of course, the internet is leaving IP. We're moving everything on top of HTTP, right? And that's all the problem with happy eyeballs. Everything is good and dandy, and we're getting the new versions. Everything is sexy. One protocol for us all. For those of you who doesn't believe that religion, we still have good old SIP. Heard about VoIP? Right? So the browser vendors sold this years ago. The SIP vendors sold this. Moving to the next slide. XMPP, while TCP-based, have the same problems as HTTP. Haven't seen any discussion about solving this. I hope they cleaned up their own mess. Oh, WebRTC in the core spec says we're dual stack. Right. How many have tested that? And in some specs, I ask, oh, what about IPv6 or dual stack? We'll take that later. Okay. When? RC3261, which is 140 pages of fun, stated early, SIP works with both IPv4 and IPv6. So we should be good, right? I mean, come on, this was in 2002. Camelio supports IPv6 from day one in our code. Staying happy. Do we have a problem in SIP? I tested it at SIPIT. I've been testing numerous times. We have issues with finding the best media path, but there are standards. Setting up a connection to signaling. Try happy eyeballs over UDP, fellows. Give me a solution to that. Finding the quickest connection where we have a connectionless protocol. setting up the best connection between users. So this is rather fun. I ended up with this conclusion. Yeah, we do have a problem. Someone is going to fix it. Oops, someone is me. Hey, join me in fixing this. Oops, guess not. So I started writing some IETF documents. I got actually a few people on board helping me write those and getting it through the whole process. So we have one RFC now, and we have 2 more drafts coming on how to fix this in SIP. What we discovered while testing was that IPv4 devices with single stacks crashed and burned, because in SIP we have IP addresses everywhere in the messages, and we injected IPv6 addresses here and there, and their software burned. So even if you're not porting your software to IPv6, you need to watch out when you have these protocols, because we're sending addresses inside. Also, when I said in my DNS that, hey, I prefer if you connect to me over IPv6, in my SRV records, the first priority was IPv6 only, the second was IPv4 and IPv6. Many implementations crashed and burned because they couldn't really understand that first priority and didn't understand that they should fail over to the second priority. And that's covered in the RFC. You're all going home to read that I actually wrote. So crashes, no connections, that's fun. Yeah. For media, we have ICE, and ICE have IPv6 additions. You have dual stacks, and the default role is if you're IPv6 only, you have to help those poor pieces of code out there that doesn't support this by going to a turn server and applying for one of these IPv4 legacy addresses. So you have to help others. Have I seen this in WebRTC? No. The biggest problem I had was in one of the core RFCs, there was a little OR. So people came to me and said, well, the RFC says I should ask for IPv4 or IPv6, and I asked for one. 5 years of fighting the OR and changing that to an AND, but we did it. We changed that. RFC. So where are we? SIP. One RFC published, one SIP forum document, IETF drafts in process. We're making progress. XMPP have the same happy eyeballs problems. I haven't seen any, don't need any RFCs, but the implementations need to test. I haven't seen that. WebRTC should work. Sounds promising, right? Yeah. We have work to do. And I believe there are many other protocols out there that have this problem. But people haven't really tested, haven't considered the impacts of dual stack fully. I think in SIP we're actually way ahead of a lot of protocols. So you may ask yourself, is this for real? Yes. Many mobile carriers around the globe, started in the US, but actually now in Sweden as well, our carrier in the radio added IPv6. We have dual stacks in all our office mobile phones. So every single journalist out there, dual stack. So that's cool. At the same time, they actually added a carrier grad NAT, and every week they keep modifying the session timers for that NAT, which is fun because then I have to modify the keep alive in my Camilo server, which keeps me busy. So they're adjusting their stuff. They don't want to occupy, as more people get on board with this dual stack server, the carrier grad NAT allocates memory for all the sessions, and they don't want to keep them in memory. So they went down from 5 minutes to 3 minutes, and now recently to 1 minute. And they also have a session limitation. We haven't found that, and they don't want to tell us, but they have confirmed they have a limitation on the number of concurrent IPv4 sessions, and they're properly adjusting that as well. So this is fun. We discovered that we have those little access points connecting to cell data. They still run NAT even though the network runs NAT. So in those cases, if we use IPv4, we have dual NATs. What can be better than a single NAT? Yeah, 2 NATs in the same session. We're happy. And that little mobile puck, by the way, had a zip helper application, an application level gateway that Iñaki so loves. So we're moving everything, all the media to IPv6 as fast as we can. So we're really pushing our vendors. And that's the tough problem. They are not ready for this. Oh, we tested IPv6 in a lab and it works. Okay, have you tested this? Oh, I wasn't aware of that. Thanks God I can point to ITF documents and real stuff in the zip forum. Not just being me, even though I wrote them. Open source, Camellia have issues with this. Asterisk has issues. FreeSwitch most likely have not solved this. And the same thing, I think, goes for a lot of these. We need to solve the happy eyeballs problems. And I need you guys to help me with UDP because that's the missing draft. You're drafted, right? It's getting painful because this is in production. It's now, really. It exists in a lot of products. We have a lot of theories. Move to TCP and you can do happy eyeballs. Fix the eye stuff and you're ready. You also need to look, because a lot of your applications, even though they're zip, WebRTCX, and PP, they use HTTP or LDAP or something else. All of these TCP connection protocols, they will have happy eyeballs problems as soon as you add IPv6 to the DNS entry. So this is now, build a testbed, fix your applications. Thank you. Oh, I see questions.
What's the RFC number? So I can look it up and read it.
Sal, my assistant, will find it soon. I think 7948. I should have it engraved here. Proud author of.
Yeah, so last year, thanks to Apple, PGC got pushed into IPv6 and everything. Everybody was scared of getting kicked off the App Store, right? One of the things doesn't mention is not dual stack, but single stack even. IPv6 to those Camellias or whatever during IPv4 only, and they have NAT 64 which is supposed to solve everything. And then obviously it fails SDP and all that sort of stuff. And I think, is there anyone want to comment on the IPv6 to IPv4?
To be honest, I haven't started testing that because I've been so fully occupied with this. We said at the last ZipIt, where PGZip was actually involved, we said that we need to install NAT64 in our test. But this has been so painful, so it's been enough. But you're right, we probably need to look into that as well. Especially with DNSSEC and other things, NAT64 can be interesting. More questions?
We got 2 more minutes, so first step. Or not.
You're happy. You're going to read all the documentation the AI downloaded.
We are all happy eyeballs now.
Your happy eyeballs. Stay in this room and the rest of the documentation will be downloaded at 5 o'clock or something into your extra memory. Thank you.
In 2 days. Bye.
Great, as per usual.
Thank you.
Thanks, Ali.
You're welcome.
Yeah, it made me think about certain things and how we should do connects and XMPP as well. We should preferably publish both addresses and simultaneously connect.
Yeah, and Jingle has the same set of problems as we have with media.
I mean,
But I mean, since you're lucky enough to have TCP, I mean, then you can just do the HAP eyeballs.
And I'm fortunate enough to live to have an environment where most of my peers do IPv6 well or not at all, and my home connection is very reliable. It's IPv6, so it's native IPv6 by the provider.